Oh, thank you very much, Steve. My name is Hiroyuki Aoki from Tokyo Park Company from Japan. I really appreciate the opportunity to be here today. I'm going to talk about DC fast charging alternative, gas station, convenience for EVs. I put some question marks there. It was not supposed to be, but I'll elaborate it later, but DC fast charger is not electrical equivalent of gas station. I'll talk it later. Okay, I'd like to today talk about the DC fast charging technology, which is now known as a CHAdeMO. And this technology is now deployed by many business corporations, government bodies, both at the federal and local level all around the world. And I'd like to explain why we have get involved in this activity, TEPCO, what CHAdeMO technology can do to advance electric vehicles. Let me touch on why TEPCO is involved in this activity shortly. Like many other power utilities, TEPCO has its goal of CO2 reduction, and it's 0.28 kilograms CO2 kilowatt-hour by 2020. That level is just above Canada, but below Italy or England. Actually, TEPCO produces its entire electricity, out of its entire electricity, 30% from nuclear power, and 10% from hydro, and 50% from natural gas. This is very clean energy mix asset, but once all these clean power sources are fully deployed, it becomes very, very costly to move further to set a higher target. And we have come to understand that this is kind of supply side technology, which on the left side, but we have to come to understand we need to move further, and to take a demand side approach is more appropriate to move further. And we call it activity switch. That is on the logo of this electric vehicle. I mean that the switch is a switch from the gasoline to electricity in this transportation sector. And in other fields, a switch from gas oven to electric oven, which is inductive. And also in terms of the air conditioning, switch from gas heating to more heat pump type electrical heating. And we estimate by switching in the transportation sector from gasoline to electricity makes 70% reduction of CO2 emission possible. This is a huge number, I think. And we touch on CHAdeMO Association. And this is an association that is established last year, not this year, I'm sorry, in March, with collaboration with Nissan and Toyota. And this CHAdeMO stands for Charge and Move. And in Japanese, it's a pun for charging will complete while you are having tea. In other countries, some coffee might be appropriate, but our culture often refer to tea. Then this is an international organization from the outset in Europe and the United States. And some media interpret this CHAdeMO as a Japanese government initiative, but this is wrong. And this R&D activity was done without any government subsidy, and many foreign companies and the government are supporting this. Now, today's main topic, normal AC and quick DC combination, which is optimal way of charging electric vehicle. That's our philosophy. The horizontal lines location. Right-hand side is public, and left-hand side is more private. And vertical access is upper side is quick and lower side is slow. We think in the private space, assuming that people have a private space to park their own vehicle, and in that private space, slow charger is most appropriate because cost is very important. Each electric vehicle have to have its own charging spot, and so it shouldn't be expensive. But in the public space, we believe that fast charging is appropriate, and the charging speed using this DC fast charging technology is if you have 5 minutes, you can charge the electricity that will allow you to drive 40 kilometers. And if you have 10 minutes, you can drive 60 kilometers. And many automakers just focus on the time to be fulfilled for the battery, but I think 5 and 10 minutes for 40 to 60 kilometers is most often used case for this DC fast charging facility. And we think in the public space, slow charger will not be appropriate anymore once the people get used to this fast charging, and occupying one space for hours just for charging doesn't make rational to me. And we touch on next, as a power company, on the issue of grid. Our specialty is grid. Typical power capacity for this DC fast charger is 50 kilowatt, which is almost same as 10 or 15 household in case of Japan, but in the United States, maybe less than 10 household. 50 kilowatt is, I mean, it's a very large electricity consumption, and it's not so easy to find a location without worrying about the place to that will not affect the negatively affect the grid. And we believe that this DC fast charger should be placed at the higher higher voltage level. For instance, in Japan, 22 kilovolt or 66.6 kilovolt. In these areas, like large shopping mall or this kind of large public facility has a large capacity to absorb this 50 kilowatt charging. But on the other hand, if you try to put this kind of charger to this 200 voltage distribution network, it will be a great impact to the grid, and it's very difficult to find a place. And you have to have some more technology, like combining a charger with a battery, but try to find a place in this high voltage area is most appropriate in my eyes. And then oh, I'm sorry, that's this. I'll touch on the this low voltage area. And this low voltage area, people use AC normal charging. And if you have an appropriate number of DC quick charger in this area, you don't have to build a large charging spot in your private space. Maybe capacity is 2.5 to 4 kilowatt would be good enough for charging because if you charge it using 100 voltage and 15 amp, you can charge 15 kilowatt hour of the electricity to your battery. That will allow you to drive 110 kilometer. As our previous speaker shown, 80% to 90% of the driving area daily will fall into that scope, so you don't have to worry about too much. But if you are encountering a situation where the battery is running out, you can find a DC fast charger and charge it 5 minutes and 10 minutes. That's a basic idea and what is now being done in the area, Tokyo metropolitan or in other areas in Japan, like Kyoto. Then total cost will be reasonable because this charger costs 25,000 US dollars for 1 unit, but you can share it according to our estimate, maybe 200 electric vehicles. And then you can share the total burden of this installation cost, and it will not cost more than 100 US dollars per person ultimately. Okay, I understand. And then I will show you some of the vehicle that is in the market and existing quick chargers in Japan. And give me 1 minute to explain. This is recently it's becoming very famous, and this is a situation where there is no quick charger in this area. This is a typical branch office in Yokohama. It's a very small space, and people can drive. If you have a 100-kilometer range EV, it will easily cover the whole area, but without DC charging, our employees never try to go far away up to the northwestern part of this branch office from this branch office. But once we put a DC charger here, the driving behavior has changed dramatically. And most importantly, that DC fast charger was not used so often. It was used a couple of times a month, and that means you really don't have to have a large number of the DC charger, which is different from the gas station. I'll come back to my title. That's why I put a question mark there. And the reason why this is different from the gas station is this is to give a sense of assurance to the driver, EV drivers, not the real fuel. And the number of the DC charger will not be so large as the number of the gas stations. And in Japanese case, we think 5,000 DC fast charger will be sufficient, while there is 40,000 gas stations in Japan. Thank you very much.
Thank you, Mr. Aoki.